Okay, students, we will start with the new techniques of inventory control. In this, we are having economic order quantity, EOQ, economic order quantity, that we will discuss today based on this thing. The inventory model deals with the idle resources like main machines, money, and materials. These models are concerned with the two decisions: how much to order, purchase, or the produce, and when to order so as to minimize the total cost. Okay, so economic order quantity we want to find out. For that purpose, how much we have to order and when to order, all these things. For the first decisions, how much to order, there are two basic costs are considered, namely inventory carrying cost and the ordering or acquisition cost. Okay, as the quantity ordered is increased, inventory carrying cost increases while ordering the cost decreases. As the quantity ordered is increased, inventory carrying cost is increased while ordering cost is decreased. Okay, but another thing is what order quantity means, and the quantity produced or produced quantity produced or quantity produced during one production cycle. The economic order quantity is calculated by balancing the two costs. What I am saying, I repeat, ordered quantity means what? Quantity produced or procured during the one production cycle. Economic order quantity is calculated by balancing the these two costs. Okay, economic order quantity is that size of order which minimize the total cost of carrying and cost of order. The economic order quantity we must know the minimize the total cost of carrying the inventory and cost of ordering. That is the minimum total cost occur when the inventory carrying cost is equal to the order cost. Minimum total cost occurs when inventory carrying cost is equal to the ordering cost. Okay, so these things we have to take into the mind, and based on this we have to find out the economic order quantity, that is EOQ. To determine the economic order quantity by analytical methods, we have to follow the following procedures. In order to derive an economic lot size formula, following assumptions are made. What are that assumptions? We will say that demand is known and uniform. Demand is known and uniform. Let D denotes the total number of units purchased or produced, and Q denotes the lot size in each run. Okay, D is the number of unit purchased or produced, and Q is a lot size in each production. Shortages are not permitted. That is, as soon as the level of inventory reaches zero, the inventory is replenished. Uh, that is the things which we are having. Production or supply of the community is instantaneous. Production or supply of the community is instantaneous. It is another our assumptions. Lead time is zero. Lead time is zero. Setup cost per production runs or procurement cost is C3. Setup cost per production run or procurement cost is C3. Inventory carrying cost is C1 and it is equal to the C into L. C into L, where C is the unit cost and L is called as inventory carrying cost, expressed as a percentage of the value of average inventory. Inventory carrying cost is C1 and CL, where C is the unit cost and L is the called as inventory carrying cost, expressed as a percentage of the value of the average inventory. Okay, these are the assumptions and the notations which we are having. For a determination of the economic order quantity by analytic method, we will follow these things. The most economic point in terms of the total inventory cost exists where inventory carrying cost is equal to the annual ordering cost. Inventory carrying cost is equal to the annual ordering cost. Average inventory is equal to the one half maximum plus minimum level of inventory. So what we are having, one half Q plus 0, that is average inventory cost is Q divided by 2. Total inventory carrying cost is equal to the average inventory into inventory carrying cost per unit length. So we are having the total inventory carrying cost is equal to the Q divided by 2 into C1, but C1 is equal to the Q divided by into C1. So it is equal to the Q into C into L divided by 2. Total annual ordering cost is equal to the number of orders per year into ordering cost per order. So total ordering cost is equal to the D divided by Q into C3. Here D is total number of units we are procuring annually is equal to the D divided by 2 into C3. Okay. Now summing up the total inventory cost and total ordering cost, we get the total inventory cost C. Total cost of a production run is equal to the total inventory cost plus annual ordering cost. So it is equal to the Q into C into L divided by 2 plus D divided by Q into C3. So this is the cost equations which we are having. By using this cost equation, we will further simplify these things. So my simplified things are like this. Q1 Q into C1 divided by 2 is equal to the D divided by Q into C3. So therefore, Q into C1 is equal to the 2 capital D divided by capital Q in the bracket into C3. Or we can have these things like this. Q we will move on the other side, that is left side. So Q square is equal to the 2C3 into D divided by C1. So simplifying that, we will get that Q is equal to the square root of 2C3D divided by C1. 2C3D divided by C1. So optimal quantity EOQ is equal to the Q0 is equal to the square root of 2C3 into D divided by C1. Optimal number of orders are equal to the D divided by Q0. So this is equal to the, we can get the optimal number of the orders. Optimal order intervals T naught is equal to the 365 divided by N naught in a days. So 1 upon N naught in a year is equal to the Q0 divided by D. So average yearly cost is equal to the, that average this cost is equal to the square root of 2C3 DC1. 2C3 DC1. So Q 2C3D into C1, which will be the, we will got this average yearly cost. So this is about this EOQ techniques. By using this EOQ techniques and analytical methods, we can find out the economic order quantity, and we can further we will discuss. In the next lecture, we will discuss about the problems based on the this. Thank you.